Welcome back everybody to part 3 of our topic for sorting data out. And what we're going to do for this part is we're going to look at how to use the bubble sort algorithm to completely sort in ascending order a set of numbers. Now I've written the index numbers of the items just above them. You can see it starts from 0, it ends at 4, and we have 5 numbers. Now when you're tracing when you're using bubble sort to trace how the numbers are ordered, what you need to do is you only need to write in a new line the new state. I'm going to repeat that. The new state of the array once two numbers have been swapped. If nothing has been swapped, you do not need to write a new line. So if we look at the array here, remember from the previous video, what the algorithm does is it checks index 0 and index 1 first, and it checks if index 0 is greater in value than index 1. And in this case, we can see that 5 is in fact greater than 2. So the new state of the array would look like this. And you can see I've highlighted the swap there. We have 2 and 5 being swapped around. Now, if you haven't figured why this algorithm is called bubble sort yet, it's a way of explaining that the values which are lighter float to the top, and the values which are heavier like a rock float to the bottom. So that's why it's called bubble sort, because bubbles would float to the top if there are any in the water, and if you throw a rock in the water, it will float to the bottom. So you can kind of imagine the end of the array here being the bottom of the water, and this is the surface over here. So that's why I've got this animation happening on screen there. Now once it has checked index 0 and 1, the next two indexes or indices that is going to look at is 1 and 2. So 5 is not greater than 7, so 5 and 7 do not get swapped. They remain as they are, and you do not need to write a new line to state the same thing. Because the state doesn't change, you don't need to write a new line. So once 1 and 2 have been checked and they are not swapped, then the next two places are that are checked are 2 and 3. So index 2 and index 3. Now index 2 is in fact greater than index 3. 7 is greater than 1. So what you would need to do here is you would then need to write a new line to say what the new state of the array is. So now 1 and 7 have been swapped. Now, as I mentioned previously, I don't remember if it was in part 1 or part 2. I think it was in part 2. Your instinct is going to tell you that in stage 3, so in the third line that you're going to write, you should write 2, 1, 5, 7, 6. So what you've done is you've swapped 1 and 5, which is correct. I mean, 5 is greater than 1, and those two values need to be swapped over. But what you don't realize is that the algorithm that is currently running is not looking at this index right now. Neither is it looking at this index right now. So after swapping 2 and 3, the next index that is, or the next indices that it's looking at is 3 and 4, not 1 and 2. So before you swap 5 and 1, you need to swap 7 and 6 here. So this would be the new state. So what has happened is the for loop has just completed its iteration. And in that one pass, in its complete loop, it has pushed the highest value in the array, regardless of where it was in or in which index it was, to the last index over here. Now we're lucky that the second highest value is in the correct position here, but that's not always the case. What's important again is that for a complete pass of the for loop, the highest value would get pushed to the end, or the heaviest item would sink to the bottom. Now the for loop is going to start again from the beginning, because remember it's inside that while loop that is going to keep restarting the for loop so that it organizes the data, or it orders the data in ascending order until it's completed its task. So now it's looking again at index 0 and 1. So once you have pushed the highest value to the end, you go back to the first index and the second index and you check those. Now 2 and 5 don't need to be swapped over because 2 is not greater than 5. So then the next two indices that you're looking at are index 1 and index 2, not index 0 anymore. And this is where you would then swap the values 1 and 5. So then your algorithm is going to check index 2 and index 3. There's nothing to swap there. Then it would check index 3 and index 4, and there's nothing to swap there with 6 and 7. So the for loop ends and it begins again from index 0 and 1. Now value 2 is greater than value 1, so we're going to swap those two values around, and the for loop again is going to go all the way to the end, checking whether it needs to do any swapping. Now once it completes that, it's going to start one more time just to check if there are no more values that it needs to swap, because in the third pass of the for loop it managed to change values 1 and 2, or indices 0 and 1. So as far as the algorithm is concerned, there may still be some numbers that it needs to change. So it will still run the for loop one final time, the fourth time in this case, just to check if there are no more values that it needs to check. Now obviously this is not an efficient way. There are ways to make the algorithm more efficient. We'll talk about those at the very end of the video. So what I want you to do is I want you to have a look at these activities here, and on a piece of paper I want you to use the bubble sort algorithm to trace them and show the work of ordering these unordered lists in ascending order. So pause the video now, and once you unpause it we will have a look at these numbers together. Okay, so if you did pause the video and you did attempt these activities, well done on you. Let's see if you managed to get them or you managed to trace them the correct way. So let's have a look at the easy one here. So we can see the first two values that were swapped over were 1 and 2. And then remember, the algorithm will be looking at index 1 and 2. So first it looked at 0 and 1. Now it's looking at 1 and 2. So 1 and 2, 2 and 5 basically, they don't need to swap because 2 is not greater than 5. So you don't need to write another line between them because the state remains the same. And then the algorithm is going to be looking at index 2 and 3, and 5 is greater than 3. So then we do need to write the new state when it swaps those two values. And then after that, we're looking at index 3 and index 4, and 5 is greater than 4, so we swap these two values, and on its final pass, it's going to check if all of the numbers are in ascending order, again, which they are. So if you trace this correctly, give yourself a nice tick, well done to you. I'm not going to explain the other ones, I'm just going to show you the answers. You check if you got them correct, and very well done if you got any of them correct. So here's the okay one. We can see that it's done 2 passes to sort everything out, and that would be 3 passes with the final one to check if it got it correct. Let's have a look at the hard one. So we can see here it's the for loop has done 1, 2, 3 passes to sort everything out, and 4 to check if everything is in order. Let's look at the brutal one. Okay, so we can see 5 being the highest value here is pushed to the end. We can see then 4 gets pushed to the end. So I'm just going to make some lines here to show you. So in its first pass, number 5 has been pushed to the end. On the second pass, we can see that the 4 has been pushed to the end. Then number 3 and number 2, like so. And this has taken 4 passes to complete and 5 passes with the final checkup to see if the list is in order. So if you get a question in the exam to sort a set of numbers using bubble sort, you need to keep this in mind and just write, each time you write a new line, it has to be the new state of the array with values being swapped. If no values are being swapped, then you don't really need to write anything. So well done to you if you managed to get any of those correct, and super well done to you if you managed to get all of them correct on your first go. Now let's have a look at another activity here. We can see that this person here, Simon, has traced these letters here, and unfortunately he's made a mistake. And we can also see Ali on this side has traced this this array here to order it, but unfortunately he's made a mistake as well. So what I want you to do is, if you want to pause the video, to check what kind of mistake they have made, so that you don't make that mistake in the exam. So pause the video now, have a look at these, and think about what kind of mistakes they have made. Alright, if you did pause that video, very well done to you for trying, and super well done to you if you managed to figure it out. So let's have a look at these mistakes here. So what Simon has done is, on its first check, he has swapped the letters S and O, like so, which is correct, because if we look at the number value for O, it's less than the value for S, so those two values are going to be swapped, like so. And then on its second line, unfortunately, when he should have swapped the letters S and R, he has jumped to the end of the array and has swapped the values S and T. So remember, the first two indices that the algorithm looks at is 0 and 1, and then for its next checkup it's going to look at 1 and 2, and then 2 and 3, and then 3 and 4. So what Simon has done, unfortunately, he's gone from checking 0 and 1 to then checking 3 and 4, which has caused him to make this error and has lost some marks in the exam. Now if we look at Ali's mistake, he's done well to not swap the I and the T, and he has swapped the A and the T because the A is of a lower value than the letter T here. But then what he has done is he has swapped two values at the same time to the left, and has pushed one value to the right, like so. This is not what the algorithm is designed to do, because the algorithm is only designed to check 2 indices at any given time. It's not going to check 3 indices like what Ali has thought it does. So unfortunately, Ali has made a mistake and he won't be getting full marks. He might get 1 mark for doing the first line correctly, but he will lose out on some marks after this. Alright, so let's look at the final slide here. And what you'll note is that this is the pseudocode for the bubble sort algorithm. What I would like you to do is I would like you to use this pseudocode here, and I would like you to code this algorithm using your preferred language. For my students, that would be C# at the moment, but if you're using Python or any other programming language, you're more than welcome to try it out in those. What I also want you to do is think about how you can make this algorithm more efficient. And two recommendations I can make right now are that because we are always pushing every time the for loop completes its loop, it reaches the end, we know that during that iteration we have already pushed the highest value to the end of the array. So the second time the for loop is initiated, we don't, for that second pass, we don't need to check this index here and this index here. So what I want you to do is I want you to think of a way to not always check these last two indices or these last two indices here if we know we've already pushed the highest value to the end. So think about how you can restrict this for loop each time the while loop initiates it, so that it doesn't have to check the last indices or the last index here, because we already know that the highest value is going to be there.